calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey folks, welcome. This is Mark D'Antonio with KGRARadio.com and SkyTour Radio here on KGRA Radio. And we are here together again. This is a live show, absolutely. We couldn't do a show last week, I believe, but this week we are live. We've got so many great doings going on up in the sky that it would be a shame not to be able to talk about it today. I'm here with my wonderful co-host, Amanda. Hi, Amanda. What are you doing tonight?
I'm hanging out with you, learning about comets.
Oh, wow. Very cool. And we also have, guess who? Daryl. Daryl Mason's with us. Hey, Daryl.
Hello, Mark. Hello, Amanda.
Hi, Daryl. How are you?
That he says to me, hello, Mark. And then, hi, Amanda. It's, come on. A little favoritism here, huh, Daryl?
Hello, Mark.
Hey, thanks.
Hi, Amanda.
Hey, that was funny. Well, anyway, guys, you know, we have a lot of fun when we do this, and you know that. Yeah, I'd like to just say a few things. You know, I want to mention that we have a wonderful producer. Bill's fantastic to us. He does a great job for us.
Hi, Bill.
Yeah, we all say hello to Bill because he keeps us going. And KGRA has big doings coming up in the future. I'll get a status on the KGRA archives as well. I know that you want to hear about that at the next break. I'll give you a status, what we know so far, and when those archives will be back up. And that will, again, we'll get that after the break. However, right now I'd like to say SkyTour live stream is the companion stream to SkyTour Radio. And it is a wonderful clear night journey through the wonders of the deep sky, all courtesy of these wonderful research-grade telescopes, plural, that we have here at the John Zach Memorial Observatory here in northwestern Connecticut, and soon in the Sonoran Desert at an amazing observatory out there that we are going to give a special name to. We're going to name it, I think, for one of the people that has been just instrumental in helping get this underway. And that's all I'm going to say for now. Now, in SkyTour live stream, what is it? Well, it's basically a wonderful live observatory on clear nights, unlike tonight. I was hoping we were going to be streaming live while doing the show because we do have a beautiful comet in the sky. But we'll get to it. It's not going to disappear tomorrow. But SkyTour live stream can show you the remnants of these beautiful dead and dying stars. They give off these wonderful shells of gas. We can view glittering jewel boxes of stars and rich clusters and see wondrous phenomena in the universe, like stellar nurseries, where life itself may eventually rise one day. We also see these beautiful once-in-a-lifetime, periodic or non-periodic interlopers that are comets. And the Neowise comet, which we're going to talk about a bit tonight, the most beautiful comet in the last 23 years, is something else that you'll see in SkyTour live stream. We just did a beautiful stream the other night, actually last night, wasn't it? We did this. I don't know. Daryl, you were with me, right? Amanda couldn't join.
No, I missed it on Friday, I think it was. Friday night?
Yes, it was Friday night.
Okay, Friday night, yeah. Well, since Friday night, we already have nearly 4,000 views on that stream that we did. And it was beautiful. Now, the comet was only up for a short time because it was just after sunset. And, hopefully we'll tell you some things about the comet, where to look, how to find it, what to see, what to expect to see, and actually how to photograph it if you'd like to, because you can. And it's really, really easy. But don't expect to do it with your cell phone. That's all I'm saying. And I'll tell you about that later. All right. Or Daryl will. Either one of us will tell you. And Amanda can certainly chime in as well because, she knows a lot about astronomy now. And, we might as well just turn the whole show over to her anyway, right, Amanda? You can do it.
Yeah, sure. Right.
See, that's confidence, folks, Mm-hmm. Well, in any case, SkyTour Livestream is also a place where you, the viewer, can also be in charge if you want to be. Just because I'm up there pointing out things and moving the telescope And we have Daryl and Amanda with us as well. Just because I'm up front doing all that stuff with the telescope doesn't mean that you can't say, hey, can we see this? Or can we see that? Or what is really cool that is really a beautiful blue color right now in the sky or something, like a nebula or something. And we will do that. Daryl sits in the background and he hunts down things and says, well, the cat's eye is up. Let's go look at that. Okay, we'll look at that. And we will actually, talk to you by name and say, hey, well, so-and-so wanted to see this particular thing, so we're going to go there now. And then we tell you all about it, tell you what it is, where it comes from, what it's going to become in the future, how it got to where it is. And, the universe is just an amazing book of knowledge if you just know how to read the book. And you just need to be given that knowledge in a way that is something that will just leave you perplexed and wondering what it was you just read, as far as a quote-unquote book. So that's what SkyTour Livestream is. And I hope you would join us out there. And if you're interested, there is also a book that has been written about extraterrestrial life, the search for extraterrestrial life, and the building blocks of life, which is part of what tonight's show is going to be about. And that book is called The Populated Universe. And it's available in 3 different formats for 3 different budgets. And it's up on Amazon. So feel free to get it as an ebook, as a small black and white copy, or the full color, larger format 8x10 color version. Did I say color? It's beautiful. It really came out very nice. I'm very happy to see that book in print. And incidentally, SkyTour Radio now has a call-in line, and that call-in line will be given later. And I believe we're still sponsored by the Paranormal app found on Google Play or on iTunes. And we'll be opening the lines a little bit later. But just to write it down now, that number is 85KGRA Live. Don't call now. We won't answer. Okay, but it's 85KGRA Live or 855-472-5483. And now on SkyTour Radio, asteroids. You may have heard some silly talk lately that a deadly asteroid is heading our way. Oh, no, get your affairs in order. There's a huge asteroid coming our way. Now, that's partly true, except it's could be deadly, but only if it veered many, many millions of miles in another direction. All right, and only if it was several thousand feet bigger in diameter than it is. So you see how these stories get legs on the internet, right? Yeah, you don't believe everything you hear. This asteroid is actually called 2020 ND, as in November Delta. Okay, 2020 ND. And it's a huge, whopping 520 feet across. All right, that's 160 meters. And it's going to fly very close to us, astronomically speaking. And when I say astronomically speaking, that should be code for nowhere near the Earth as far as we're concerned. Okay. Now, it first zipped by us in July of 1945, and it's done it 4 times since. And it's going to do it again now on the 24th. And you're going to say, oh, no, can we see it? How will we see it? Well, the next time, if you miss this one, those that are younger could see it in 2035, and maybe 2074 after that, and 2145 after that, and so on. This time, it's going to pass us relatively close. And what does relatively close mean? 14.5 times the distance to the moon. Okay, so that's 5,570,000 kilometers, or 3,461,037.5 miles. So, yeah, it's
approximately, as Mr. Spock would say.
Yeah, it is approximate, Captain. Thank you, Mr. Spock. I am impressed. So
3 digits, but approximate.
Right. Exactly. Yes. So our normal exoplanet roundup will return next week. But I wanted to just tell you about that asteroid because I was asked by Heidi Gadd, who is someone who is also helping with SkyTour Livestream. And Heidi had asked a question in a message to me earlier, and I just wanted to give her the courtesy of giving her credit for asking that question because that's a really good one. All right. Now, she asked the question of whether we would see it or not. And the answer, Heidi, for you is No, it's only 500 feet across, and it's going to be over almost 3.5 million miles away. So at 500 feet across, it's going to be way too dim for us to see, even with the SkyTour live stream telescope. So it is a very dark asteroid. All right, most of them are actually. So there you go. That's Heidi's question. If any of you have questions that you want to hear answered on the air, you can write me, or you can write Amanda or Daryl at SkyTour Radio at kgraradio.com. Or if you have my messenger address, you can send questions to that, or you can ask me in Facebook, or Amanda, or Daryl. Well, Daryl doesn't use Facebook. He's not there.
Nope.
Okay. Yeah. But you can ask me anything you like, and I will, if your question is really cool, like Heidi's, I will answer it on the air, and I will also give you credit for it and tell you, hey, that's cool. And check out Heidi's stuff. She's fantastic. She's an amazing musician. So there's something else to do. So we here on SkyTour Radio, you've heard me say this before. Daryl and even Amanda have said this before. We always talk about these building blocks of life, right? And we talk about the fact that we're based on carbon. That's something we just know, but because we have analyzed ourselves and we know our DNA is mostly carbon. It's made of carbon-based compounds. But it's actually kind of a carbon-centric universe in a sense. And the carbon compounds that we care about, the carbon-based compounds, are the ones that will go into the formation of objects that can be classified as living things. Things that can reproduce, things that are self-aware, things that are self-directed, and things like that. So that is sort of a simpleton view of what life is, because as humans, we're all simpletons when it comes to understanding what life really is. But it all starts with carbon for the human race. And there's people out there that say, well, what about other forms of, of life? What about, I've heard silicon-based life. What about that? Well, we've seen no case for that anywhere. Every life form on the planet here developed from a carbon base. Now, if silicon could have been a life basis, I would think that we would see examples in pockets on the planet of silicon-based life. We do not. Every living thing on the planet has DNA, and deoxyribonucleic acid. Remember that? That's what it is. And it's a double helix, and it's these nucleotides that are bonded to each other. They can be unzipped, and they're duplicated, and the DNA will unzip, and that half a helix will go to a certain place in the cell, and the location in that cell will zip up a new strand to match what's there, duplicating the DNA. Right? So that process is something that actually potentially causes the symmetry that we have, the bilateral symmetry. You're the same to the left, same to the right on your body through the center. That's also a characteristic of life on this planet, is the bilateral symmetry. So I suspect that carbon is a template in the universe. I've said this a few times to you guys. And that template is something that we would find ourselves looking for as a carbon-based life form, But the question is, and we really never really went down this path fully, where does the carbon come from? How is it that it's so important in the universe? How is it made? How is the carbon made? That's kind of an important question. And one of the questions we're going to answer tonight. Now, there are some of you out there in the audience who know enough about stars that that there are ways in which stars make elements. We've talked about them. It's called stellar nucleosynthesis. So stellar nuclear synthesis of different elements. And there are several ways in which stars generate energy, because it is stars where this occurs. And oddly, or as we'll see, it's only in stars where the carbon content really comes from in the universe. And that's a pretty interesting statement, considering that you might think there's big clouds of carbon floating out there And there really isn't. There are carbon compounds in clouds and molecular carbon at places, but there's no carbon repository just sitting out there and being distributed to the universe. So how does it happen? Well, when we look at a star like the sun, stars like the sun are kind of a middle ground star. There are stars that are far more massive and more hot, as Amanda likes to talk about with the stellar classification that we talk about from time to time, and she might get a chance to do that again tonight. And then there are stars that are much cooler than the sun. But as a star starts its life, all stars have in common the fact that they do hydrogen fusion. All right? All stars do hydrogen fusion. There's two ways in which stars do hydrogen fusion. We're going to talk about one of those tonight. And the reason I talk about that is because this is where carbon comes from. But you have to understand how it works. And I'd like to really make sure that I drive home that point. So here's how it goes. When a star like the sun is fusing hydrogen to helium, and you look at the sun in the sky, you say, wow, look at that entire star, burning and fusing helium out of carbon. No, the only place it's happening is deep inside the star in the core. That's the only place that fusion's occurring. And you might say, well, wait a minute, what's all that big bright stuff then around the outside of the star that we're seeing? Well, that is the gas that the star was made from. And the gas is so hot that the atoms of this gas no longer have their electrons associated with them. You're looking at atomic nuclei, just the nuclei of the atom. And the electrons and the protons that make up these atoms are all free. All right. You still have like a helium atom that's, say, two protons. Well, you still have two protons together. Okay. But the two protons together don't have two electrons going around them in an orbit. It's way too hot, way too energetic. And so you would just have these free protons and electrons flying around inside the star. And this is what we call plasma. Okay. Now that plasma is mobile. It moves and it leaves the star. It heads out from the star. The star is blowing this stuff out because it's so energetic from in the core. And that energy pushing outward not only holds the star up because it's always trying to shrink and contract under its own gravity, but it also pushes this plasma out into space. We see that the sun is giving off what we call the solar wind, high energy particles. And by particles, I mean protons and electrons that are coming toward us from the sun. And when they strike us in great numbers, well, we get aurora borealis. That's where our northern lights come from. And thank you. I'm glad we see those, because if we didn't, then you wouldn't see anything except your skin turning black, because you would be getting basically burned from this high energy radiation that is actually being stopped by our magnetic field. And when it spirals into the magnetic field and gets trapped in there, because they're charged particles coming from the sun. After all, protons are positively charged, aren't they? And electrons are negatively charged. So if they're all separate, well, they're charged. And if they interact with our magnetic field, then they're going to follow magnetic field lines. And as they spiral down, they interact with our atmosphere and cause a glow in the atmosphere that we call the aurora. And it's really and they're beautiful to see. If you've never seen them, I really recommend it. Some of the nicest places to go to see the aurora is actually in northern Norway. When I was there last August, I wished I could have gone up north. We couldn't make it. We were speaking we were in the West Coast. Actually, Bergen was the highest we got, and we couldn't go farther north. So if you get a chance, check out auroras. You can also see them here. And what you're looking at is you're watching the magnetic field saving your life, frankly. And that is a very good thing, as you may imagine. So now, when these protons and electrons in the sun are in that outer envelope, then the part you see with your eye when you take a chance to look at the sun, you don't actually see the part that's generating the energy that keeps you warm. you're actually seeing only that outer plasma, all right, which is floating in the outer atmosphere, what we call the photosphere of the sun. What you need to look for, which you cannot see, is deep in the core of the sun. And that's where the temperatures are highest. That's where the pressure is highest. And you need high temperature and high pressure to make nucleosynthesis work, to make fusion occur. And in our sun, we have a process called the proton-proton system, the proton-proton process. It's been called a chain reaction. It's really not a chain reaction. Okay, it's called the proton-proton process. And it really is it's only operating on these nuclei. In the core, you absolutely only have nuclei since it's too hot for bound electrons. All right, and what does it do? You have one hydrogen nucleus. In other words, a single proton. And you also have neutrons. Now, protons are positively charged. They're +1, right? And neutrons are neutral. They don't have any charge. They just add mass to the atom. So you have a hydrogen nucleus that gets joined by a neutron. And that forms what we call deuterium. What's that? Well, deuterium is a hydrogen nucleus where instead of just one proton, it has that neutron with it. So you have these two things in there, a proton and a neutron, deuterium. And deuterium is a variation of hydrogen, of the hydrogen nucleus. We call that variation an isotope. And isotopes, if you might remember from the last times we've talked about this in the past, they're all variations. So the neutrons are the only thing that tell it what isotope it is. Two neutrons make it a different isotope than one. All right. The proton number doesn't change, but add neutrons, it changes the isotope. In other words, what flavor of ice cream is it? Well, it's still ice cream. It's just that this is chocolate because it has an extra neutron. Okay, and this is vanilla because it's missing an extra neutron, and and this is pistachio because it has 3 neutrons. And that's really the difference. It's still ice cream. Follow? So that's the analogy here. So the deuterium then that is formed, the deuterium atom, is actually just that proton plus the neutron, and it joins with another helium or another hydrogen atom, a hydrogen nucleus, and it forms a helium nucleus. So a proton plus a neutron plus another proton, okay? Because hydrogen has one proton, and that extra neutron just kind of goes along for the ride in deuterium. And then the hydrogen atom combines with it to form an isotope of helium called helium-3. Now, you heard about that before, I think, because we talk about the fact that some of the lunar rock has helium-3 in it. That's actually very important. It's one of the fusion fuels, and it eliminates a bunch of steps. If you can find the helium-3, well, then you don't have to make the helium-3. You don't need to spend energy to make the helium-3. And from there, we can go to other products to make the fusion process work. But this helium-3, okay, is just 2 protons and a neutron, okay? So 2 helium-3 nuclei can combine, and they form what's called helium-4, okay? And what's that mean? Well, it means 2 protons and 2 neutrons, okay? And what's left over is 2 more hydrogen nuclei. So basically it gives back 2 hydrogen at the end and energy, all right? And the helium-4 is what's made in the end. And that right there, the helium-4, that's the thing that ends up getting and accumulating in the core of the star, all right? Now, helium-3 is, like I said, 2 protons plus 1 neutron, right? So the result of this is helium-4 is 2 protons plus 2 neutrons plus 2 hydrogen nuclei, 2 protons, all right? And that is the result, all right? And you get a lot of energy out of it. Now, that helium-4 nuclei being 2 protons and 2 neutrons, they will build up, as I said, in the core. Now, stars like our sun will keep doing this process. This is the proton-proton chain, okay? Basically, hydrogen becomes helium-4, okay? The isotope of helium that has 2 extra neutrons in it. And when the sun runs out of hydrogen, well, then the outer pressure, the outer radiation pressure is going to slow down. and the star is going to contract, and the core is going to heat up. And it's going to heat up to maybe about 10 times what the current temperature is now. And that starts a new process. And that new process is something that can now fuse helium into other things. And that's something that will take us a little bit longer than the few seconds we have left. So I would just say for you now, when we come back, we'll talk about the next process. And then after that, the most amazing thing happens. And this will tell you where we come from. But more on that when we get back on SkyTour Radio. This is Mark, Amanda, and Daryl. We'll be right back.
Hi, folks. It's troubling times, and fear is pushing emotions, which in turn pushes health the wrong direction. Do you ever get an ache because life is uneasy? Try Life Change Tea at getthetea.com. Life Change Tea works on your digestive tract, helping to move food through quicker and comfortably so your health is spot on. Life Change Tea may not help with world issues, but it will help with your digestive issues. A glass a day helps keep the intruders away. So, change your life today. Log on to getthetea.com. That's getthetea.com. If your health game is off, get on by ordering Life Change Tea. Getthetea.com. And while you're on our site, look around at the great non-GMO organic supplements. And if you're a sales shopper, go to our specials page and see what's for you. I've been drinking the tea for 12 years, and I'm sure glad for its health benefits. Again, that's getthetea.com. Getthetea.com. The tea that makes you go.
When you're in the house for longer periods of time, you can see them flying or running across the floor. Ooh, yuck. They're unhealthy, gross, and disgusting. Bugs. I loathe bugs. We keep a clean home, but occasionally bugs show up. Well, I found something that is tougher than bugs. Orange Guard. On contact, it kills hidden bugs, including ants, roaches, and fleas. Plus, Orange Guard is a residual repellent. All of the ingredients of Orange Guard are on the FDA generally recognized as safe list. Orange Guard may be used around food, humans, and pets. It comes with a 30-day money-back guarantee. Orange Guard. Available at orangeguard.com, Whole Foods, and Ace Hardware.
The Liberator Rocket Heater will heat your home for free. The highly efficient Liberator Rocket Heater has no moving parts. It's safe and strong, constructed of quarter-inch steel. So like all things made in the USA, it's built to last. Uses any kind of wood, sticks, even scrap in its gravity-fed firebox. And it heats workshops, homes, garages, outbuildings, industrial areas, and barns. Watch the video of this blast furnace stove in action. Visit rocketheater.com. That's rocketheater.com.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now. The Paranormal Radio app, free in Google Play and the iOS App Store.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey, welcome back to SkyTour Radio. This is Mark with Daryl and Amanda. And we were talking about where carbon comes from in our universe before the break. And it was very important to talk about that because we have to really set up and understand where this carbon content, where this abundance is coming from. And we talked about this we kind of dug into the hydrogen fusion a little bit to see that our sun would be left with helium-4 in the nucleus of the sun, the core. But when the sun runs out of hydrogen, it's going to end up going toward the red giant stage, right? It's going to swell. And then a new process takes over called the triple alpha process. And this is going to involve these helium-4 nuclei. And what that's going to do is these helium-4 nuclei are going to be able to combine and form some lithium, which goes away really quickly because it's not stable, some beryllium, which also goes away because it's not that stable. But there's a certain point where the amount of beryllium produced is so high that the beryllium could then combine with another one of these helium-4 nuclei. And guess what it forms? A carbon atom. And so that carbon atom that's formed is a stable atom. And it takes a star that's already on the basically the end of its life to do this. And it's all about amounts here. You know, it's actually an isotope of beryllium called beryllium-8. Okay, that just means that it has some extra neutrons in its nucleus to give it a different flavor. And as we get these carbon atoms, the carbon atoms are an isotope called carbon-12. Now, you might have heard of that, right? So you get carbon-12 plus some energy. So you're always getting energy out of these reactions. So it's a somewhat confusing process that gets us to carbon-12, but it's stable. And it's a really good thing that the triple alpha process happens, because when the Big Bang occurred way, way back when, 13.6 to 7 to 8 billion years ago, depending on whose research you're looking at, we wouldn't have found very much carbon, because the carbon needs to be formed under higher temperatures than there existed at that time. So that's how some of the carbon gets formed. But there's new research, thank you, Amanda, who brought this to our attention, that says that white dwarfs in clusters of stars can tell us more about where carbon comes from. And it turns out that white dwarfs are very important in the realm of generating carbon for the universe. And so that research was incredibly important. So thank you, Amanda, for that story. It was very important to learning about where this carbon comes from, because it's not just one place where it's generated. It's being generated in a number of ways. Okay, so white dwarfs, and through this process within stars. And when stars die, they send some back to the interstellar medium. And now, for those of you familiar with the night sky right now, we have other carbon-based generators, you might say, that are out there. But it's not just our star that has them. Other stars, it turns out, have vast cometary systems. Okay, one of them, and Daryl, you might know the star. There's another star out there that has at least 3 comets that have been identified around it. Do you know the star?
Not offhand, no.
Beta Pictoris.
Oh, okay, sure.
Yeah. And
Beta Pictoris was the first star that we discovered what would you call it, a planetary disk around?
Exactly so. And now we know that Beta Pictoris has at least 2 planets in formation, if not formed. But see, as time goes on, we're also, just because we find them, we don't just leave them alone and say, okay, we found a planetary disk. Okay, no, we go back and we look to see if anything new has changed, or if our new capabilities can show us more details about what we thought we knew. Now, there's another star out there that we've actually seen in SkyTour livestream, and that star was Tabby's star. Astronomer Tabitha Boyajian found this star that seemed to be dimming in the Kepler data. And they tried to say that maybe this was actually a swarm of comets traveling around Tabby's star that were causing this occasional weird dimming by up to 22%. They've since backtracked on that theory. They don't think maybe that was it. Maybe it was like another process that was taking place. But what's interesting about comets is that they formed way at the beginning, not lately. They formed way at the beginning. And the things that comets are made of can't exist near a star. They have to exist far away, because the star would melt them away and evaporate them away. As you see, when you look at Comet Neowise in the sky, what do you see? You see a comet with a bright head and a tail behind it. Well, that tail is being generated by the evaporation of the comet overall. All right. And the sun probably has many trillions of comet-like bodies out in its outer shell out beyond what we call the Kuiper Belt and in something called the Oort cloud. All right. And this is kind of where comets come from here. And there's been several planets, actually 2 Kepler planets in particular, the Kepler Space Telescope planets that were found, that have also been found to have transiting exocomets, comets that actually went around and cut off the light of the star by a little bit. So this is interesting because, we found evidence of 3 of them so far, and the transiting exoplanet survey satellite, TESS, actually found the 3 around Beta Pictoris, right? So that's really cool. And Beta Pictoris, as Daryl said, has belts of dust around it. Now, it has dust, but it might also have larger bodies. We know there's at least 1 or 2 planets that are going around Beta Pictoris. One's around 2.5 astronomical units from the star. The other one is over 9 astronomical units from the star. And that's, distance Earth to the sun is an astronomical unit. So you can see that there's a lot going on there. It's an extremely active solar system, a star system, I should say. And now, with such a bright comet that's currently visible in your sky, you have to wonder about these amazing interlopers. And there's some history to comets. For instance, they were characterized as long-haired stars, and the records were kind of excellent in terms of giving us the historical record for the future, I guess. And they used to cause hysteria. I think, Daryl, we talked about this before. You remember some of the hysteria, right, that was generated by some of the purveyors of doom for the early commentary appearances, yes?
Oh, yeah. Shakespeare once said, the skies themselves foretell the deaths of kings.
Yeah, that's right. And
we always could use more Shakespeare in our shows.
Well, feel free.
I agree.
I wish I knew more to quote. I love that. That's beautiful.
Yeah, it is. And
it always seems like astronomy inspires poetry and inspires the arts. Not only science and math and stuff, but
sometimes it inspired fear too.
Yeah,
I bet. If you couldn't explain it, that would have been terrifying.
Yep.
Yeah, to give you an idea, okay, Daryl has a fun story to tell us about Camille Flammarion, and he was like the Carl Sagan of his day. And I think that Camille's experience shooting off his mouth about comets kind of got him in trouble. Daryl, do you want to relay that story at this point?
Oh, sure. As Mark said, Camille Flammarion, he was a French astronomer, I guess. He was a popularizer of science. He was much like the Carl Sagan of his day. This is back in the latter part of the 19th and early 20th century, I believe. Very popular guy, and a lot of people read his work. This was still in the dawn of science becoming part of astronomy. Is that really fair to say? They were still learning. They detected so-called cyanide in the tail of the comet. I guess we might call it cyanogen now. Yep. And Flammarion postulated that, if Halley's Comet and this 1910 apparition came close enough to Earth, we would actually pass through the tail of the comet, and it could gas everybody on Earth, kill millions of people or everybody. And that was a little extravagant. He scared a lot of people. This is where comet pills came from, patent medicines, snake oil. They were selling pills, supposedly to keep you safe from the cyanogen in the gas tail. But it was just to make a quick buck. Yeah. All sorts of hysteria. I'm sorry.
I always wonder how they test those. How do they actually test that? If they're putting out the pills, didn't anyone say, did you test it on anything? And the answer was undoubtedly, no.
Yeah, well, they were patent medicines, snake oil. And anyway, it didn't happen. Comet Halley came and went, and we flew through the tail, and everybody lived. Interestingly, along the same line, Sir Arthur Conan Doyle, the author of the Sherlock Holmes stories, he wrote a story about a very similar scenario. not long afterwards. And it's in a book called The Lost World, which is a collection of stories about a guy named Professor Challenger. The Lost World itself was actually, I think, the genesis of all the Jurassic Park movies. It's an interesting tale about dinosaurs being discovered in the modern world down in South America, if I remember correctly. But anyway, Professor Challenger, who was a very arrogant guy, he said, well, golly, we're going to pass through this field of gas out in space, and, here it comes. And he and some friends locked themselves in a house out in the country with lots of cylinders of oxygen, and they tried to maintain their atmosphere inside the house as long as they could, and they ran out of oxygen. And everybody in the world appeared to start dropping dead. Being after Flammarion, I don't know if people could have taken all this with a grain of salt by then, or if it really still scared people. But everybody keeled over like they were dead. But hey, the next day everybody woke up again. Anyway, Flammarion took it on the chin because of his over-enthusiasm about the poisonous gas tail of the comet. Now, when we see comets nowadays, that gas tail, that ion tail, it has a typical blue or green color. That's caused by carbon compounds. I read somewhere the other day that a lot of the carbon that we're seeing in the tail of Comet Neowise is actually carbon dioxide, but I'm sure there's cyanogen there too.
Yeah, carbon dioxide, cyanogen, yeah.
Yeah. But anyway, that's it. And, we're not going to die from the tail of the comet.
I like the end of that story.
Yeah.
We're not going to die. Wonderful.
Everybody lives happy after.
Yeah.
But still, comets, for whatever reason, they have always scared people. Is it going to hit us? Is it going to kill us? Is it foretelling the death of kings, so to speak? Who knows? You can speculate about all this.
Oh, yeah. But to be honest, I guess I never had that fear because, of course, none of us really did because we never grew up in that era where you would basically hide under the covers to protect yourself from a comet. But on the other hand, you have to think, we are in light polluted skies. There's a lot of people out there that don't even know there's a comet out there right now. If we were under dark skies and you went out, you would actually see the comet with your naked eye, and under, even in some relatively low light polluted areas, you would see the comet in the sky. I'm going to have Daryl tell you later where you can see it and what the best way to view it is, because that's a lot of fun. And if you were in SkyTour livestream a couple nights ago, we actually did a Comet Neowise stream, and we showed the comet for the 45 or 50 minutes that we could see it. Because unfortunately, the comet is low to the horizon. But we'll figure out. We'll tell you where that is in just a little while. But comets throughout history, as he said, have caused panic. From 1200 to 1650 A.D. That was the highest level of panic at that time. There was a great comet of 1618, right? And it was stated by clerics to be a sign that Judgment Day was coming. Rivers would change course. Earthquakes would destroy cities and towns. And at that time, you put all your faith in clerics and the church. So you thought they were telling the truth, and of course, hot and dry weather would come and hailstorms would happen, poor harvests and war. Well, when have we not had hailstorms and dry weather and hot weather and so forth on this planet? I mean, you're bound to be right at some point, And then there was the great comet of 1680. It was going to be responsible, you see, for worldwide floods, as in the book of Genesis. How? By looking at that giant tail, of course, they were told that it was all made of water and it was going to pour all over the earth. Because isn't that what comets do? No, of course not. But that was the prevailing faulty understanding at work, just like Flammarion's faulty understanding of cyanogen. Now, cyanogen chemically is a carbon atom, that ubiquitous carbon atom, bonded to a single nitrogen. That's cyanogen, CN. It's if you bond it with another hydrogen, make it HCN, that's actually hydrogen cyanide, which we know, of course, is very toxic. Cyanogen's toxic as well. But the fact of the matter is, this chemical is seen in the coma of the comet, and it's actually responsible for a lot of the green color that we see. And the coma is the head of the comet, and that fuzzy area around the front end of the comet, like that fuzzy area can be hundreds of thousands of miles long. Comet Holmes actually had a coma that was the size of the disk of the sun, so over 800,000 miles across. Huge. I believe, and Daryl, you know this. We talked about this. I'm not sure what the what the diameter of the coma is here, but wasn't it like 8 to 15 Earth diameters for Neowise, the latest comet?
I don't really know offhand. I know the actual comet body itself is 5 kilometers or 3 miles.
Yeah.
And comets generally do. The nucleus we see, coma, whatever you want to call it, it's a whole lot bigger than the actual comet body. You're talking probably many thousands or hundreds of thousands of miles.
Yeah. Well, the bottom line is, and the key takeaway from what Daryl just told you is, the nucleus of the comet is this little tiny, tiny pipsqueak that, left alone, if it wasn't doing anything, like, causing all this gas to come off, if it was just inert and not doing anything, you'd never even notice it. But the fact that you see it is because of all this really, really excited gas that's being ionized, that's being caused to glow. And then the tail of the comet, there's 2 tails of the comet. Daryl told you about the ion tail. That's the straight tail. There's a straight tail sticking out from all comets. And they're always pointing away from the sun. Even when they're leaving the sun, when they pass around the sun and they're heading back out into space, they're heading right into, well, relatively speaking, into their ion tail. They're heading into a tail that's sticking farther out away in front of them. And that's the ion tail. But then all this material that's in the nucleus that gets sent up into the area around the comet and then just drifts behind because of the pressure of the very light itself that's hitting the comet, that forms the dust tail. Now, the dust is actually small particles. That's not gas. It's particles, little grains. And these can be frozen grains. They may glow very brightly. They have knots and twists and kinks in them, just like the ion tail can. The ion tail is created chemically. The dust tail is a result of all of that chemical activity blowing dust off the comet as well that's on there. Billions of years of accumulation of dust, as a matter of fact. And when we look at the comet, like Comet Neowise, well, what we see is a comet that has actually been here before. It's actually a periodic comet. And it has its orbital its orbital characteristics are such that it's in a very, very highly elliptical orbit. Okay, and that highly elliptical orbit is going to take it back to us again at some point in the future, and we'll get that information and give you all that in a little while. But you're probably not going to be around for it, but you're around for it now. And what I'd like to do actually is have Daryl tell you how to see the comet, and then we can tell you how you can actually take photos of it.
Okay. I've got my hands full here. If you go out about 9 o'clock at night, it probably won't be quite dark yet. Some of this depends on where you are in your time zone and how north or south, how far north or south you are. But if you can find the Big Dipper, it's starting to set now. That is, it's dropping in the northwest after sunset. If you can find the Big Dipper from mid-northern latitudes, it's at 9 o'clock. It's going to be about 40 degrees above the horizon. The bowl of the Dipper, the bottom lip, the front of the bowl, will be about 40 degrees up. And if you look about halfway down toward the horizon from the bowl of the Big Dipper, that is where Comet Neowise is tonight. Now, the comet is rising a bit night by night, shifting its position. If you're familiar with the entirety of Ursa Major, the Bear, not just the Big Dipper, tonight and tomorrow, the comet is pretty much to the left, some degrees, of the nose of the Bear. It's a little bit above the front foot of the bear tonight. And again, it's going to be rising a bit night by night. It's going to be getting higher, but it's also going to be getting dimmer. The comet is already dimmed quite a bit. And from a dark sky, you should see something. I can't guarantee you what you will see. It's predicated very much on the light pollution levels wherever you live. Myself, for instance, besides the weather, I'm looking through all the light dome along the Front Range of Colorado from the Springs up to Denver, and my chances of seeing much of the comet naked eye are nil. You'll probably have much better chance if you use binoculars, and the comet should image beautifully with a digital camera. But you may not see a lot naked eye.
Yeah, it's actually magnitude 6 right now, so that's fainter than the eye can typically see in regular conditions anyway.
Mag 6, really? Last I heard, it was about Mag 2. I thought.
Well,
a thing about seeing comets, though, well, if they say like it's magnitude 2 or magnitude 6, they mean the equivalent of a stellar magnitude. And the difference is when you see a star that's second magnitude, well, it's fairly bright. When you look at a comet that's second magnitude, especially if it has much size to it at all, it's that same amount of light spread over the entirety of the comet. So it's not going to look very bright necessarily.
Yeah.
That's why comets are better when they're big and bright.
Yeah.
And this is why I've been saying a lot of people have been calling Neowise a great comet, and I would hesitate to use that term. It's a good comet, maybe not a great comet, just because there's not a lot to see naked eye.
Yeah.
But it does take images very well.
Yeah. I mean, the estimated magnitude right now is 6, but they also have another magnitude, COBS, right? I think that's the combined magnitude, and it's 1.8, which is, I think, the number you were referring to. But
okay, well, I'm looking at the Sky Live, and by gosh, it does say magnitude 6 tonight, which means it has dimmed a lot since
2 nights ago.
Yeah, it passed closest to Earth.
Yeah, it was 2 nights ago. It was magnitude 3 in the skylive.com. And we recommend all of you look in the skylive.com, actually. And you scroll down and you can just pick an object you want to see. Usually the biggest one and the biggest text is the one that's highly interesting to most people and the most searched on. And that's the one where right now it's Neowise. You can see Comet Neowise. It's theskylive.com. And then you have charts and everything. It's really quite nice. And I would think that when we get SkyTour Livestream West up and running, there's a lot of comets out there actually in the sky right now. I mean, there is Comet Enki out there now. There's a number of other ones. There's Pan stars. Comets are not just Neowise and then no more. At any one time, there's 4 to 5 comets that we can actually see, not with our naked eye, but image with the telescope. So you can see that the universe is full of things that are always moving through the sky. And in some cases, stars, too, because we've seen stars that move in the space of 5 or 6 months. You can actually tell they've actually moved in the sky. They'll never return to that other place again. This is really interesting. So that said, when we look at Comet Neowise, I mean, there have been some great comets in history, and most people know Halley's Comet. Halley's Comet was here in 1910, and that's the one that Camille Flammarion was talking and making his pronouncements about. But he wasn't, in my view, trying to frighten anyone. He was just speaking as a science guy. It has cyanogen. Cyanogen's poisonous to people. So if we were to go through the tail, who knows, we might die from it. I mean, that's probably the nature of how he said it, but I wasn't there. I'm really not that old. But the thing is, this cyanogen is really important because when the sun hits the cyanogen molecule, the cyanogen molecule can be caused to glow, right? And that glow is a typical green color that we see, and that's from that cyanogen. So when we look at this round nose of the comet, that coma, it has a green tint. And if you saw SkyTour Livestream, we showed it was a green tint. We pointed out, we talked about it. And then the tail was sort of a feathery looking, dusty looking, kind of reddish, not reddish, but orangey, whitish orange tail. And that whitish orange was more due to the fact that we were looking at the comet low to the horizon. As Daryl said, it's actually pretty low to that northwestern horizon, but it is getting higher night by night a little bit. And the tail did seem to have a fairly orangey look to it. But hey, I tell you, this is looking for comets is really a lot of fun. We have a good time, and we're going to be doing more of it in SkyTour live stream. So I will tell you right now that I think that we will be looking at more comets in the future. Okay, so with that, I will say hang on to the other side because we have another break, and we shall return in just a few moments. We'll be right back.
I'm getting older and noticing that my body just doesn't work as well as it used to. So I like to keep fit as possible by hitting the gym a few times a week. Recently, I started having a nagging bicep pain, and it got so bad I couldn't even lift the weights. When I was complaining about it to a friend, he told me about Angioprim. He said chelation helps remove toxins, heavy metals, and cholesterol in veins and arteries that may cause blockages. After just 1 week of taking Angioprim, the pain was gone, and now I'm back in the gym full strength. Scientific research proves the active ingredient in Angioprim has superior oral chelation action that helps promote cardiovascular health. So to learn more, go to angioprim.com. That's ANGIOPRIM.com, or talk to a trained consultant. Call Angioprim toll free at 945-882-7221. You'll feel better with more energy. That's 945-882-7221. Or go to the website angioprim.com.
Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied. But you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to AncientLifeOil.com. That's AncientLifeOil.com and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with, you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Telepath is a weekly digital newsletter filled with the latest paranormal news, trending topics, and fresh articles from some of the most popular critical thinkers in the community today. Stay informed on your favorite paranormal podcasts and live streaming talk shows. Interact with the Telepath and upload your paranormal story or pics. It could be featured in an upcoming edition. Sign up right now for the free Telepath newsletter at paranormal.radio. That's paranormal.radio. In 2019, the KGRA is closing down its archive vault to be reopened in another format in the near future. This year, you can get all the 2019 KGRA programming on demand on YouTube, Spreaker, iTunes, Spotify, iHeart, and Google Play. More ways for you to stay connected to your contact for alternative talk radio on the planet, KGRAradio.com.
Now you have the inside contact for alternative talk radio. The planet, KGRAradio.com.
Hey, welcome back to SkyTour Radio. This is Mark with Daryl and Amanda. We are talking comets tonight. We have Comet Neowise in our northwestern sky, and that's Neo, N-E-O, and Wise, W-I-S-E. And I separate those two because this telescope, this space telescope that saw the comet, started life as the WISE telescope. All right, that's the Wide Infrared Survey Explorer. And it actually found other things. It was looking for near-Earth objects and asteroids. It was also looking for other asteroids in the far solar system. And it was sort of quietly out there doing its job. And its life was extended with a near-Earth object, near-Earth object role. And it became NEOWISE. And so every time NEOWISE finds an object like a comet, which were of particular interest to this secondary mission, it's called, NEOWISE, and then a designation, like, to tell you more details about it. So that's the instrument that found it. The NEOWISE and WISE, the satellites are one and the same. It's just that they were a repurposed mission. So one thing I wanted to mention overall, by the way, was if any of you have any questions, feel free to post them in the chat, and we'll be happy to answer them. And right now, I'd like to go to Amanda to see if we have any questions waiting for us.
We do, and I like this question. This is a nice, simple, straightforward question, and I think the answer is going to be interesting regardless which answer it is. Ronald wants to know, which is older, the comets we see or our sun?
Ooh. The sun.
That's interesting. Very interesting.
Don't tease it out or anything, Daryl.
Okay, everything in our solar system formed from the solar nebula that grew around the nascent sun, shall we say. The sun had to form first, and all the mass of the original nebula that the sun formed from, imagine like the big spinning disk that gathered and eventually collapsed in the center to form the sun. Everything else in the solar system formed from the leftovers of what the sun formed from, including comets. As Mark said earlier, the stuff that was way far out there in the far reaches of the solar system, where it was so cold the sun couldn't evaporate it away, that's what formed comets.
That's right. Those, and of course, Daryl speaks truthfully every time, and in this case, no different. Our solar system has a sort of a architecture to it. We have the inner planets, Mercury, Venus, Earth, Mars, and then we have the outer planets after an asteroid belt, and that's Jupiter, Saturn, Uranus, Neptune, and Pluto. Yeah, that's right. I think Pluto's a planet. Okay. I don't care what anybody says. And I'm sure that Daryl and Amanda can weigh in on that later. But I can tell you this, beyond Neptune, all right, to stick with conventional thinking about the outer universe, outer solar system, we have what are called TNOs. Okay, TN is in November, O. The TNOs are trans-Neptunian objects. These TNOs are objects beyond Neptune, of course, that are icy bodies. Now, Pluto just happens to fit the profile of these outer TNOs, and so it was designated a dwarf planet after much deliberation. And it does have 5 moons of its own, so it's quite a heck of a dwarf planet. But that's okay. That said, beyond Pluto even is a belt of objects known as the Kuiper Belt, Kuiper. The Kuiper Belt is a bunch of icy bodies that, as Daryl said, are so far away that the sun's radiation couldn't and doesn't evaporate the materials off their surfaces. Yes, the sun still has an effect out there. Yes, some of the compounds are in the inner Kuiper Belt closer to Pluto. Some of those compounds are altered and changed. But in the far Kuiper Belt, and even farther in the cloud of objects around the solar system called the Oort cloud, O-O-R-T, okay, the sun's light doesn't have an appreciable enough strength to actually cause anything to happen to these. So they are in the deep freeze, inert, nothing happening. So in a sense, there could be trillions of these objects, and in a sense, any one of them depending on their overall size, could be a small or large comet, couldn't it? If it ever came into the inner solar system, it's going to boil away some of the accumulated ices that are on its surface at some point in time. And I think that's really kind of an interesting thing to talk about. And speaking of that, talking about different sizes and different masses and different appearances, we find that not all comets were the same. And this is something that I want to let Daryl talk about. He mentioned earlier that in the break that he might want to talk about this. So I'll give him the opportunity to take this and run with it for a little while. Go for it. Okay.
All righty. First, I'm going to throw a wrench in the works of what I just said. We had, at least one interstellar comet visitor, Comet Borisov, as I remember correctly. I have to assume it formed around another star and wandered through space somehow, got flung out of its stellar system or whatever, and eventually wound up here. But ultimately, who knows where it came from, and how it formed. But on to what Mark just said. Comets look different, and they've been described differently, as Mark said earlier. I think it might have been the Chinese who called comets hairy stars. Hairy as in, hair on your head. Not all comets look the same. The last time Halley's Comet came around, this is all predicated on how big the comet is intrinsically, how close it passes to the sun at perihelion, how close it passes to Earth. So, we get our closest view of it, all sorts of things, and whatever the comet is made of. These can all affect what the comet looks like. We talked about Halley's Comet, its 1910 apparition. Halley's Comet came through again. It was on its way in 1985, and it headed back out in 1986. I saw Halley's Comet, I think, about 70 different occasions on the way in and on the way out. The best I saw Halley's Comet was in the morning sky. I think it was March 21st, 1986. It was just to the left of the handle of the teapot in the morning sky. The tail was about 10 degrees long. It was really pretty, but it wasn't terribly impressive just because it was rather far away, so it didn't look very big. But the comet's head was a little bit to the left of the handle of the teapot in Sagittarius, and the tail was 10 degrees or so long and extended across the handle into the body of the teapot. It was a pretty sight. I saw this naked eye before, right at first light. It had been cloudy that morning, and the clouds rolled back right at first light, and there it was, just big as life. It was really pretty. Different comets look different, though. When Hyakutake came in 1996, nobody was expecting it. It just, it was discovered, and then it showed up in pretty short order, as I recalled. Hyakutake looked like a great big blue-green spear flying across the sky. For what I could see, it looked like it was 100% gas tail. I didn't see a big dust tail with it. So the tail was straight and skinny, and it had a barbed spear head shape to it, and it looked for all the world like a great big blue-green spear flying across the sky. It was big. Hyakutake was not intrinsically a big comet, but it came close to the Earth. I forget, maybe 10 million miles away. And it looked really big in the sky. It stretched more than halfway across the sky. The night it was closest, it passed under the North Pole, as I recall, the pole star, Polaris. And you could actually see it moving in the eyepiece of the telescope at that time. But it looked for all the world like a great big blue-green spear with a barbed head flying across the sky. Wow. The very next year, Comet Hale-Bopp, which looked like sort of like Neowise's bigger, brighter brother, I said before, the best look I got it in. I also saw Hale-Bopp many occasions in the morning and the evening sky on the way in and the way out. Hale-Bopp had a huge, kind of a broad curved fan of a dust tail, which was the color of the sun, and it had a bright blue-green gas tail right under it. It was beautiful to see. The point I'm trying to make is that every one of them looked very different than the others. And comets tend to do that.
Yeah, they do. And I want to thank you, Daryl. That was wonderful. And if you guys get a chance to see this comet, please head outside right after sunset and look toward, as Daryl said, the northwest, under the Big Dipper, as we talked. And you might need a pair of binoculars. Now, you will need a pair of binoculars now to see it. But you'll see a fuzzy spot. I'm not sure if the tail has changed appreciably in the last 2 days. You'll still see the tail hanging in space, but I don't know what's coming off the comet now. I don't know how much is outgassing. So I'm 2 days behind. And with comets, that really makes a huge difference. And I want to tell you, we're trying to pull it off tonight, and up to about 10 minutes before the show tonight, maybe a little longer, I was hoping to have the observatory live right now and have SkyTour live streaming at the same time, so that we can actually show you the comet at the same time as doing our radio show. And that might have been broadcast on KGRA DB. And unfortunately, the clouds just thickened up too much for us to show anything. And I feel bad because Amanda and Daryl were both hoping we were going to do this, and but without a sky, we can't do it. And that's what. Welcome to astronomy. It's like live radio, as Amanda says. Welcome to live radio, folks. When something goes wrong, but honestly, when things like this happen, hey, we roll with the punches. Because we can't control the clouds. Well, not yet, anyway. I mean, there might be a technology. Take away our clouds, but that might pile them up on someone else, and that's not fair. But so it's pretty cool. So, one of the things that I get questions all the time about comets, and people say to me, "What's the difference between a comet and an asteroid?" Well, initially you would say, "Well, an asteroid's made of rock, a comet's made of ice." Well, actually, no, that's not true. Okay, a comet is made of the same materials potentially that some asteroids are made of, but usually these are objects from the Kuiper Belt, where there is a mixture of ices mixed into a rocky substructure. And as the ices melt and go away, well, now they're the cement that was holding this sand and grit and particles and rock to each other. And as it melts and goes away, well, that stuff's liberated and flies away. And that becomes the tail of the comet, the stuff we see illuminated by the sun.
We actually had a question along that very lines.
Okay.
From Dobb. He asks, could the tail also be electromagnetic plasma as opposed to freezing gases evaporating?
Well, okay, that's actually a very good question. When Daryl mentioned the ion tail, it's called an ion tail for a reason. It is an electromagnetic tail, okay? As the sun's plasma that we talked about when we talked about how the sun's radiation is going from the sun, these high-energy protons with electrons are going onto the comet's surface and striking it. There's no atmosphere to protect the comet. And this stuff interacts with that material, and it will chemically go after some of the compounds. It will melt some of the ices, and it will ionize other molecules and other atoms. And it also will force these materials, these particles, to stream back away from the direction that the solar wind is flowing. So in other words, you get a bluish-looking tail, as Daryl had told you earlier, heading away from the sun. No matter which way the comet is going, that blue tail is always aiming away from the sun. And as the comet goes around the sun, that blue tail will swing around literally 270 degrees as the comet goes around the sun. And then it'll be pointing away from the comet, and the comet will be heading into it on the way away from the sun many times, So it's really kind of a fascinating fascinating process. So when you say, can it be electromagnetic plasma? Well, yeah, the plasma is ionizing with these compounds and causing this streaming ion tail. However, frozen gases evaporating are also liberating particles of dust and dirt and material that becomes the dusty tail as well. So every time the comet goes around the sun, it's evaporating a little bit more. It doesn't get recharged. It's going to eventually go away. So comets evaporate over time. Maybe when it gets far out into the Kuiper belt, it could have a collision with something else and retain some of that debris and kind of be rejuvenated, I guess, in a little bit, but not generally. Typically, comets are going to fade. Halley's Comet is not a forever comet. It comes back every 76 years, and every time it's going to be a little bit fainter, a little bit fainter, a little bit fainter. So it'll eventually not even be here anymore. It's going to evaporate fully. So, but that's a very good question. I want to thank Dob for sending us that question. That was excellent.
Mark, can I address that a little bit or ask you a question about that?
Sure.
Okay. Well, differentiating between comets and asteroids, the so-called rock comet Phaeton came to mind, which is the source of, I think it's the Geminids, if I remember correctly, the Geminid meteor shower.
Yeah.
Care to talk about a rock comet as differentiating between comets and asteroids? Rock comet sounds like a snow, what is it?
Sounds like a band.
Yeah.
Ladies and gentlemen, the rock comets. Yay! Well, interesting point. Okay. The universe is full of gray areas. And this is one of those. In the Kuiper belt, these objects out there might be called icy bodies. If they make their way into the inner solar system, they're called comets. However, once the comet has all of its ice is gone, what's left behind? A rocky core. So that's the rocky core left over at the end, and that will continue to orbit the sun. So when we see some of these objects that come by, these near-Earth asteroids, for instance, these near-Earth objects, these NEOs, could it be, and I'm saying this because I kind of know the answer, could it be that some of these objects are actually potentially former comets that have since, I won't say burned out because that sounds like they're just burning away, but evaporated all their ices and the rocky core left over is all that's left over? Is it possible that maybe that's what we're looking at? And the answer is that maybe that's true, yes. So as far as the difference in these objects, we have to be careful. We can't just say, well, an asteroid's made of rock and a comet's made of ice. It's not true. Okay? An asteroid can also be made of a lot of ice. I mean, look at Ceres, the biggest asteroid. It's called a dwarf planet, right? In our asteroid belt. Ceres is loaded with water compounds. So if Ceres was closer to the sun, would Ceres outgas? Maybe in some areas it would. We know that it's actually outgassing now. It's sending out salty compounds. There's a crater that was mistaken for being illuminated by two bright lights, and they said, "Look, there's alien life there. There's two lights. Somebody left their lights on in their alien home." Well, in fact, that was just an illusion created by the fact that the asteroid is actually so dark that they have to overexpose it to make it look gray. And so these salty deposits that are in the center of this crater called Akatur crater were actually so bright in the overexposed setting that they look like two bright lights. And you can make any dark object look bright if you expose it long enough. All right. So I was really hoping that it was alien life. I mean, I would have loved to have found out that Ceres was really hollow and there was a civilization living in it. Oh, that'd be great. But the likelihood of course, dissipates as we get to it. And, of course, the Vesta probe, the Dawn probe, I think, went to the asteroid Vesta and went to Ceres. Vesta is dry as a bone. Ceres is exactly the opposite. And it was targeting those two types of asteroids for that very reason, to see what a dry as a bone asteroid looks like versus a wet asteroid or dwarf planet. And that's what it did. And so we see the difference there. I know that when we look at some of the other asteroids, again, out in the Kuiper Belt, we know that all of them are going to have icy components to them. All of them. There's no just plain old rocky ones out there. Now, we might have old comet cores out there, possibly, but the truth of the matter is that we're going to find that any of those objects out there could become comets, most likely, if they got into the inner solar system.
Would it be fair to say then that comets and asteroids, you might make a continuum between the two? That Whipple's old idea about calling a comet a dirty snowball. On the other hand, then at the other end of the spectrum, that an asteroid might be an icy mudball.
Well, Ceres certainly is a dwarf planet that's sort of an icy mudball as well. So yeah, that's actually, and that's a very good point, Daryl. And I think that needs to be, hit home here. And it's a good job. If we look at comets and asteroids, we can't just say one is this, that is that. We have to actually have a graded difference scale between the two, because some can become the other. Okay. A comet could become a small asteroid when it's expended all of its ices and is now just a rocky core, if it's a rocky core. Some may not be. Some may be more like, and this is some of the case with some comets, sort of spongy in a way. So the interior has lots of voids. Okay. And so those are things that may have started life as like rubble piles, like asteroid Bennu. Okay. That we're at now as a human race. We're out at Bennu. Bennu is really got a cool shape, and it looks like a rubble pile asteroid. If we were to bury a big nuclear weapon right down in the soils of Bennu and we exploded it, Bennu would probably become this gigantic, debris pile that's flying all over every direction, because it's being held together by its own mutual gravity, but it's really just a pile of rubble that has sort of attached to each other, but not cemented to each other. So if you hit it hard enough, if you were a big, universe god and you just punched Bennu, it would splatter like a snowball. And the parts would go all over the place because Bennu is more like a rubble pile asteroid. Comets, if you imagine if something like that is far out, if a comet is far out in the solar system and it's not a comet yet, it's an inert object. If one of these spongy, void-filled asteroid-type objects is out in the outer solar system and it's getting filled with ice and material like that over time as it was forming, if that does get perturbed or disturbed by a passing star or some other objects out in the Oort cloud beyond the Kuiper Belt and manages to find its way into the solar system and starts going in an elliptical orbit around the sun and becomes a periodic comet, all right, well then we will be looking at a comet that can probably survive for many billions of years because it probably has ice through and through. But when it evaporates, it's going to have nothing left behind because it'll be evaporating down to the smallest particles that formed it in the beginning. So a graded scale is a very good idea, Daryl, and that probably makes sense. And in fact, there's a semblance of that now in terms of how asteroids and comets compare to each other. But I wanted to go through that too, and I'm glad you threw that in. That was excellent, about how comets and asteroids will have a similarity between them. So I don't know, Amanda, do we have any more questions out there? Because we have like about a...
But if people have them, keep them coming.
Okay, because we only have like a minute left in this segment or so, I think.
What happens after that?
Huh?
And what happens after the break?
Oh, well, then we're going to open the phone lines.
Oh.
Didn't
Get ready,
you know?
guys.
You knew that.
Yeah, but did they?
Yeah, the phone lines are going to be open, folks. And then if you remember the phones, it is 85-KGRA Live, 85-KGRA Live, or 855-472-5483. 855-472-5483. Act now. We'll send you Slim Whitman's greatest hits. No, we won't. I'm just kidding. So, when we get back, we'll talk about some more basics of the Comets. We'll also talk about a little bit more about how you can photograph the comet, because I told you we would do that, and we're going to do that. All right. So we will do that when we return. And I want to also mention that when we look at a comet's orbit, we grade the comet's orbit based on how much elliptical nature there is to it. A perfect circle, all right, a perfect circle has a value for this circularity of 0, okay? And that circularity quantity is called the eccentricity. And that basically says, and I've mentioned this before, how uncircle-like it is. If it's 0, it means it's not at all uncircle-like, and therefore a circle. Yeah, I know, it's backing into it, but that's how it's thought. That's how it's thought about. And comets.
That after the break.
I know we have to go, and I'm seeing all kinds of stuff, but I'm not seeing any times here to go. I saw 2 minutes and nothing more. And Amanda, thank you, because you know what, she's really good at trying to keep me going here, guys. So we'll be right back after this break. Thank you for listening, and
Hi, folks. It's troubling times, and fear is pushing emotions, which in turn pushes health the wrong direction. Do you ever get an ache because life is uneasy? Try Life Change Tea at getthetea.com. Life Change Tea works on your digestive tract, helping to move food through quicker and comfortably so your health is spot on. Life Change Tea may not help with world issues, but it will help with your digestive issues. A glass a day helps keep the intruders away. So, change your life today. Log on to getthetea.com. That's getthetea.com. If your health game is off, get on by ordering Life Change Tea. Getthetea.com. And while you're on our site, look around at the great non-GMO organic supplements. And if you're a sales shopper, go to our specials page and see what's for you. I've been drinking the tea for 12 years, and I'm sure glad for its health benefits. Again, that's getthetea.com. Getthetea.com. The tea that makes you go.
When you're in the house for longer periods of time, you can see them flying or running across the floor. Ooh, yuck. They're unhealthy, gross, and disgusting. Bugs. I loathe bugs. We keep a clean home, but occasionally bugs show up. Well, I found something that is tougher than bugs. Orange Guard. On contact, it kills hidden bugs, including ants, roaches, and fleas. Plus, Orange Guard is a residual repellent. All of the ingredients of Orange Guard are on the FDA generally recognized as safe list. Orange Guard may be used around food, humans, and pets. It comes with a 30-day money-back guarantee. Orange Guard. Available at orangeguard.com, Whole Foods, and Ace Hardware.
Every 2 seconds, someone needs blood. Whether it's a natural disaster or one single child suffering from illness, the American Red Cross stands ready to supply blood when it's most needed. But blood is a perishable product. Therefore, it must continuously be replenished. You can safely donate blood every 56 days. The need is constant and patients are waiting. Call your American Red Cross at 1-800-GIVE-LIFE to schedule your life-saving appointment. Please give blood today. Patients are depending on you.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now, the Paranormal Radio app. Free in Google Play and the iOS App Store.
Hey everyone, this is Nick Redfern and you're listening to SkyTour Radio with Mark D'Antonio on the KGRA network, and so are the Men in Black.
Mainstream media's most wanted. KGRARadio.com.
Hey folks, welcome back to SkyTour Radio, and this is our final segment for this evening. And if you have a question, you may call us at 85KGRA Live, and we will be happy to answer your question. Your question can be addressed to either me, myself, that's me, or Daryl, or even Amanda as well, because she knows a lot about astronomy. She just isn't telling you guys. Okay, so ask her a hard question. I'm sure she would love to get one. And that number is also 855-472-5483 if you'd like to talk to us. So do give us a call. We'll be happy to take your call. Now, before the break, we were talking about cometary orbits, how the comets orbit. And one of the things that we want to talk about on that is that comets can be very elliptical in their orbits, right? And that means that it's a closed path. They will go all the way around the sun and come back again and again and again, right? The other process that can occur is that comets can be on what's called a parabolic orbit. And that's where they come in and they go out and they don't have a closed loop at the other end, which means they are not periodic. They won't come back. They're one time. Now, I think we already have a caller, and I'd like to ask Amanda if she could bring us that caller.
I'm certainly going to try. Just keep in mind the call is on KGRA, so if I accidentally hang up on you, please call back. But our first caller is... Hi, welcome to SkyTour Radio. Can I get your name and where you're calling from, please?
Hi, this is Ronald from Minnesota. Hi, Amanda.
Hi,
and
Ronald.
hello to Mark and Daryl.
Hey, Ronald. How's it going?
All right. All right. Doing good. I think you answered all of my questions. Yeah. Answered all my questions on that I had in line. So,
why'd you call?
But maybe I can ask one more. Now we mentioned Halley's, however you say it, 76 years. Do we know the orbit of this particular comet we're looking at now, Neowise?
Neowise has an eccentricity of 0.99, which means that it's an elliptical orbit. So we are able to get what are called orbital elements for this particular comet. I don't know them off the top of my head. They're very little esoteric numbers that you don't know what to do with them unless you know all about orbits and stuff. It'd probably take half a day to show people what those really mean and how they work. And you could look at orbital elements and kind of get an idea. And they're on the skylive.com too, actually. You can go see orbital elements for all of the known objects that we see. But yeah, we can get those.
Well, thank you for the live show. Yeah, go ahead,
Daryl. What Mark was saying earlier about circular and elliptical versus parabolic or hyperbolic, if it's elliptical, it's a periodic comet. It could be a short period comet. That is, it's not, it's orbiting around the sun, but it's not taking very long, a few years maybe. It's a periodic comet. Now, Comet Neowise in this case has a period, the last I heard, thought to be about 6,800 years, which is why that ellipse was described up in the high 0.99s, I guess. So it is a periodic comet, we would have to say, but it's going to take almost 7,000 years before it comes back again.
Yeah,
so we won't be here to see it. Now, if the comet is on a perihelic or a perihelic, I guess that's what parabolic or a hyperbolic orbit, it is not a periodic comet. It's, to the best of our knowledge, it's a one-time visitor.
Right. That means the eccentricity is the amount of ellipticity to the orbit. If it's 1 or greater. All right, because 0.999 is what this one's orbit is. So it's really, really, really narrow ellipse, a long, thin ellipse. But if it's 1, it's parabolic. Greater than 1, it's hyperbolic. So 1 or greater means it's a one-time visitor. Borisov, for instance, was a one-time visitor. Oumuamua was a one-time visitor as well, because even asteroids and things like that can have orbits and elliptical qualities as well. See what I mean? So, follow
I would add too that periodic comets. I don't know if Sky Live shows this or not, but if we know their orbits well enough, they describe a series of little loops across the sky, rather like those epicycles, or what planets Jupiter and Saturn are doing right now as they move through opposition. We see them make a loop in the sky. And all that is, with every loop, like Halley's Comet, for instance, with a 76-year orbit, well, we can watch it move back out into space, and every year it makes a little tiny loop in its orbit across the sky. And that loop is the Earth orbiting the sun.
That's right. And the image of the comet as seen against the more distant stars is going to seem to shift. And that shift that we see is called parallax. Yep. And that angle of the parallax can give us the exact distance to the comet. Now we have for Neowise, if you look on the skylive.com, we do have all of the information about its orbit. We have its orbital inclination. We have, what it is to the plane of all the other planets, how high up it is. We have the distance when it's far away and the distance when it's near. Okay. And when it gets far away, Neowise is going to be 715 astronomical units away. That's pretty far. And that makes sense.
Yeah, that's pretty far.
Yeah, it is, considering that Neptune's 30 astronomical units away. So clearly,
and then you did mention that the asteroids and comets mostly come from the formation of the solar system itself, correct?
Yeah, everything was formed right around the same time. That's in the body and plane of the solar system, including all the planets, the asteroids, the Kuiper Belt, the Oort cloud. All of those things formed at roughly the same time.
Interesting. I like that.
Just Thank you for my question by accident.
Yeah.
Did he?
Yeah, I had a question on what you said, Mark. When you said Oumuamua was a one-time comet, well, what if that was just the first time that it's been here? And we don't know. Or what if this is like the beginning of the cycle? No, because it had to have been created at that time. Can we possibly get a new comet? See it for its first time and
Oh, yeah, well, sure. Actually, that's a very good question. And actually, I've had that question before from folks. And one of the things that you would understand or could understand from all of this is that the solar system is dynamic. Yes, the planets have these resonant cycles between each other that they orbit each other at certain rates and so forth. Like Jupiter's Galilean moons have a particular resonance. Ganymede goes 4 times around for Europa's 2 times. I'm sorry, 1 time around to Europa's 4 times to Europa's blah. It's 1, 2, 4 resonance. Okay, so 4 times to 2 times to 1 time. Okay, so 4 times around for Io versus 2 times for Europa and 1 time for Ganymede. Okay, so that orbital resonance is something that was set up over billions of years of stability working out in the solar system. But things are dynamic here. If a star passing by far away happens to perturb or cause a disturbance in the orbits of these distant objects, then it could start those objects on a millions of years journey toward the star here. And thus we might see a new comet. So there's no way to say that hasn't already happened, because it has. These comets that we see now, the periodic comets, these are guys that we've known about, or we think we've known about. Or Neowise didn't come through here before that we have seen, because that was thousands of years ago. So we saw Neowise for the first time, in that sense, because it's got such a long period. However, Comet Encke, ENCKE, I think has like a 3-year orbital period, and that's been through here quite a lot, and so we can always expect to see that one because it doesn't really go very far away, and when it comes back, it evaporates a little more and so forth. So that's so we do and can see new comets. There's no doubt about it.
Should add too that comet orbits can change over time. Due to like gravitational influences when they pass the larger gas giant planets, mostly Jupiter. Yeah. And in an extreme case, it can be captured by Jupiter, like Shoemaker Levy 9 was.
That's right. And we certainly, I think that you said you were able to observe it, right? I observed it. Spikes. Jupiter is the biggest gravity well in the solar system besides the sun. So it necessarily needs to be taken into account, and you have to really, mind what Jupiter's doing and how it influences everything.
Yep.
It actually keeps the asteroids. The asteroid belt is this vast array between Mars and Jupiter of all these many asteroids, thousands upon thousands, hundreds of thousands of asteroids. Yet, if you add them all together, you'd find out that they are less than a fourth of the moon's mass. And that's hard to believe, I know, but that's what the estimate is for the total mass of the asteroid belt. It's not very much.
Oh, wow.
But Jupiter being out there, Ronald, okay, and this is Ronald's radio show now. We're talking about Ronald, talking to Ronald.
Aren't you glad he called? What an insightful question.
I know, it's true. And so Jupiter, being the shepherd of the outer solar system, has kept the asteroid belt from ever coalescing into one tiny little fourth moon-sized object. As Jupiter is in its orbit, okay, the asteroids are all moving faster than Jupiter because they're closer to the sun. The closer you are, the faster. Mercury goes 88 days, takes 88 days to go around the sun. Pluto, 245 years. So the asteroids are moving faster than Jupiter, which is farther out. So as the asteroids pass by where Jupiter is, they get pulled away from their orbit just a little bit. And that gentle perturbation on an ongoing basis has been enough to keep them from forming. But it's also been enough to cause some collisions, which could bring some of those asteroids into the inner solar system and may be responsible for some of the solar system objects that we call near-Earth objects, or asteroids that cross the Earth's orbit. See, so it's a dynamic place. It's always changing, and yes, we can see a new comet. We can also see a new asteroid that comes through that we didn't know was going to be there. And luckily we try to find them, and that's why we need to build up defenses to protect ourselves from a potential hit, because it's happened before. It will happen again.
Happens every day.
Interesting. Well, thank you very much for your show and the call.
Oh, hey, Ronald, thank you for the call, man. It was fun.
We can't let him go. What are we going to talk about?
What?
Oh.
I'm just teasing. Thank you very much for your call, Ronald. Take care.
Have a good
night. Me up.
Bye-bye.
Yeah, that's a good one. All right, bye, Ronald. Thank you.
As for Jupiter and comets, Jupiter's influence can be so much that it can turn a long period comet into a short period comet. Maybe over the course of several passes, but it can do that.
I imagine that has already happened.
Uh-huh.
Yeah.
Countless times.
Countless times, that's right. So, and as Daryl said before, we do have short and long period comets. And these short period comets are defined as having less than 200-year periods. That is, times that they come back again. Long periods are 200 to potentially many thousands of years, such as Neowise. Okay, and as we said, the long period comets come from farther out and have these higher eccentricities. The higher that number, as long as it doesn't reach 1, the higher that number that gets close to 1, 0.999, which is what the eccentricity is for this comet that's right here now outside in the northwest. That number, the higher, value means that the orbit is more elliptical. So very, very narrow, very, very long. And as I mentioned earlier, Neowise has a distance from the sun of over 715 astronomical units. That's huge considering that Neptune's 30. So we won't see it for thousands and thousands of years, and they have these higher eccentricities. Once they reach 1, that's when they are no longer periodic. If they start off this way, then they may stay that way. But as Daryl said, influence from Jupiter could cause them to either be ejected from our solar system if they get too close, or to be reduced in their period so that they actually become short period comets, maybe less than 200 years. I don't know, Daryl, and maybe you do. Okay, because you are basically what I would call an astronomer's astronomer.
Oh, stop.
Okay, I'll stop.
Well, go ahead.
I was going to ask you, what's the shortest period comet that has ever been discovered? I don't know the answer to this. I'm asking because I genuinely am curious. I thought it was 3 years.
Maybe Enki. I really have no idea.
Okay, I just was asking in case you did.
Yeah, I mean, if Enki has a 3-year period, well, golly, that's pretty short. I wouldn't expect it to last forever.
Yeah.
Enki's not really a major comet anyway. It may have already gassed out much of its volatiles.
Yeah. I remember talk of Enki when I was a kid, because we've known about it for so long. And back then, I seem to remember a real big to-do about Comet Enki. Enki's coming, and it was supposed to be a huge deal. So maybe over the last, few decades, a number of decades, it's actually, as you said, gassed out already.
Could be. Don't really know.
Yeah.
Enki was an astronomer in his own right. Of course, I guess he discovered the Enki division in the rings of Saturn.
Yeah. Yeah. We have the Enki gap, don't we?
Yep.
Yeah. Very cool. And so as I was saying, we do have these short and long period comets, like Daryl and I talked about. And these higher eccentricity guys, like this comet here today, Neowise, they originate in that Kuiper belt way past Neptune, and from what we call scattered disk objects, and these are called SDOs, scattered disk objects, and they're close enough to Neptune that it can gravitationally affect them, and maybe they're the reason that they get dislodged from that orbit and get pulled into the solar system and head toward the inner solar system. And we have also longer period comets. If you remember Atlas Y4, we actually looked at Atlas Y4 in SkyTour Livestream. You remember that, Daryl? We did Atlas Y4, right?
Oh yeah, we did Atlas. We tried to do Swan, I think.
Yeah, we did Holmes. Remember, we actually watched Holmes move through the eyepiece over the course of the night.
Yeah.
And I did a little video, a GIF file showing it move over the course of one single night. And Atlas Y4, on the other hand, well, that was the one we saw. It has a period of 6,000 years. That's a long time, and it comes from way far out. Way out beyond 50 astronomical units. Out in that tenuous sphere of objects that are really loosely held by the sun, almost out past the Oort cloud, into the Oort cloud, actually. So, I think that maybe since the solar system is more complicated than just having planets and a few asteroids, it also has these trillions upon trillions, potentially, of icy bodies out there, any one of which can become a comet if it gets in here. I mean, we really have to watch our planet. We have to take care of it and try to protect it from potential destruction, And the idea is that we want to be able to, leave this planet at some point and use technologies that can get us to leave this planet. I think we actually have a question from someone in the chat that kind of borders on that question about whether we can use other materials to leave the planet. And I it was there, Amanda. I think it's there was a question that came in, correct?
Yeah. Are you ready? Yeah.
Yeah.
Well, they said they thought it wasn't specifically about comets, but if you see the link, Galaxy wants to know, could we get neutron dust from a dead star and use it as gravity on a spaceship? Very interesting. Thank you for the question.
Well, okay, yeah, that's a very interesting question. Well, let's talk about that for 1 second. Neutron dust. Okay, let's I suppose by that what Galaxy is saying is, can we take a piece of a neutron star and use that for gravity? I can't answer what we might be able to do with a very, very high gravitational source. Keep in mind, a teaspoonful of a neutron star on Earth, if you could put it in a teaspoon, it would weigh billions, with a B as in beta, billions of tons. A tiny teaspoonful. I can't imagine, and most people can't imagine, material that dense. But that's what we look at with a neutron star. And I think that it would be interesting to study the concept. I think it would be really interesting to see if we could actually get neutron star material and see if we can do something with it. But you have to understand, the neutron star material is held together by the very nature of the entire neutron star itself. All right. So I'm not sure that 1 billion tons of material is going to do anything other than just cause the ship to be 1 billion tons more massive. I don't know what we can do with it. The bonds that are holding those neutrons like that would have to somehow be maintained. And the only reason they're maintained is because of the fact that the star is so massive overall. It's trying to collapse the entire time. If you took a teaspoonful away, well, that material is no longer bound to the star. And it wouldn't be any use to you. It would just be a teaspoonful of neutrons, which would all just dissipate and go away. There's no reason why they would be held together.
I would wonder if they wouldn't dissociate violently, to say the least.
Well, yeah, you're right. I mean, there's so many things that, we're glossing over here for sure. Like what, it's like saying, what if you took a spade shovel and kind of dug into the surface of a neutron star? Well, the answer is a neutron star's surface is actually as hard as granite in a sense, and it's actually this material that is so compressed. And when a neutron star has a fissure in the surface, the hot radiation from inside can flash out, and we call those pulsars, when they actually are rotating fast after a supernova. And the pulsar is like a lighthouse beacon in space. It's flashing us with all this hot material. Luckily, we're not near any, because every time they would flash us, we stand a chance of getting one heck of a tan. So let's see. Before we go, let's see if there's more questions out there, Amanda. I'll go for it, and Daryl can go for it too.
There was one. Ronald wanted to know what the gravitational distance to the sun was, if you happen to know offhand.
Gravitational distance of the sun?
Yes.
I don't know what that even means.
I don't know what that means. I mean, we are 93 million miles away from the sun. And at that speed, we have the orbital speed we need to stay in orbit. Mercury needs to be faster speed because it's a lot closer to the sun. Is it 38 million miles or so? And we don't have the need for that much speed to stay in orbit. Planets further away can orbit slower because the gravitational force drops by the square of the distance away from the source. So really, I'm not sure. I'm not sure what that means. And I think that it's really important to understand that in astronomy, as astronomers, we learn every day, and we know that everything that we learn today could become yesterday's bad data. And I think it makes sense, for instance, if we look at what when we look at, say, comets now, and we think we know how the comet's going to interact, but as it leaves the solar system and goes back out into deep space and becomes inert again. Not a nerd, but inert, I-N-E-R-T. I'm the nerd. But if it gets inert again out there in far out space, we might lose track of it. We know it's there, and maybe we can actually capture it with a particular telescope at some point. But it's going to rapidly get to the point where we don't have the ability to see it anymore. And that magnitude could be well above magnitude 35. The higher the number, the fainter they are. There are things out there with that are magnitude 23 right now, comets, in fact. And they're so small and so far away that's why they have such small brightness values as well. And speaking of brightness values, the bright light of our evening is about to go out, folks. We have had a wonderful time with you for these last couple hours. And we've enjoyed your company and your questions. And, I would hope that maybe you'll join SkyTour live stream and enjoy the live astronomy from the observatory. All right. And until then, until I see you next time and we see you next time. Okay. Until we see you next time on SkyTour Radio, we wish you the best. And remember, when you go out, keep looking up.
You never know what you'll see.
That's right.